right, so now we're looking at a polynomial, third degree, but this one has four terms. How many terms in this polynomial? Okay, so there's four terms in there: a cubic term, a quadratic term, a linear term, and a constant term. So how do we solve this? This does not fit into the quadratic pattern. Okay, it does not, the difference of cubes. All right, so this one is going to require something different. All right, and so thinking back to a couple weeks ago when we did factoring quadratics with the leading coefficient, we had one strategy called factor by grouping where we would rewrite it so it would have four terms. All right, so when a polynomial has four terms, okay, we want to check if factor by grouping works. And what factor by grouping is we split, okay, the work into two halves. We group it, first group, second group. All right, and we want to make sure we group it with that sign as part of the second group. All right, so we just ask ourselves now, GCF, what is the GCF of these first two terms? And so the only thing that goes into x cubed and negative 2x squared is x squared. And so when I factor out that x squared, that leaves me with x minus 2. All right, and now I look at this one, negative 9x and 18. And what do those have in common? They have a 9 in common, and it's going to match. I want to take out whatever this sign is. I want to keep that sign the same. So I'm going to take out a negative 9, and that leaves me with x minus 2. And why did this sign change? Because I took out a negative 9. So 18 divided by negative 9 is negative 2. So factor by grouping will work if these two parentheses are the same. All right, if those two parentheses are not the same, then it's not factorable, okay, by grouping. So now, how do I'm not done yet, okay, so this first one has an x minus 2, the second one has an x minus 2. That is, again, a common factor. So I want to take out the x minus 2, so I'm going to write the x minus 2, and when I factor that out, okay, that leaves me with an x squared and a negative 9. So it's going to leave me with x squared minus 9. All right, and again, so all I'm doing is I'm taking these out, I'm factoring it out, pulled it out in front. What's left? X squared minus 9. Right now, I could technically, I could keep going. All right, if it said to factor completely, I could keep going because x squared minus 9 is the difference of two squares. So I could go x plus 3, x minus 3. And it doesn't, you don't have to do that because this was a solved question, all right, but you can. And so solving, my answers would be 2, negative 3, and positive 3. All right, so let's try that again. Okay, you try it now. All right, so pause the film. Okay, you try this one and then watch the work when you're done. All right, so again, I'm going to split this into two groups. Okay, and look at the first one. What's the first one have in common? And that's an x squared. That leaves me with 2x plus 1. And I look at the last one here, and so what are those have a 4, and that sign's positive, so a positive 4. And that leaves me with 2x plus 1. So again, my parentheses are the same. So factor by grouping does work. Again, for factor by grouping to work, you need to have four terms, an even amount of terms. We're only going to do four terms in this class. All right. And it doesn't matter the degrees, but we need to make sure there's four terms. Okay. And once you split it in half, once the parentheses are the same, we know factor by grouping works. All right. So once I get this, I know that one of my factors will be the 2x plus 1. Okay. And then whatever's left, right, I take that out. What's left? What's in front, right? The x plus 4 is the other factor. Oops, I forgot the x squared there. Sorry, x squared plus 4. And now I'm solving. Again, I couldn't even factor that if I wanted to because it's plus 4, not a minus 4. So this answer is going to be a real answer. I'm going to get x equals negative 1/2. But over here, I'm going to get an imaginary answer, right? I'm going to get x squared equals negative 4. And then when I square root both sides, I'm going to get x equals plus or minus 2i. Again, notice I still got 3 answers, matches my exponent, my degree, right? 1 real, 2 imaginary. Okay, so we want to match these up as best as we can here. So when do I do factor by grouping? All right, when do I do the quadratic pattern? So we just learned factor by grouping, that needed 4 terms. So I'm going to match, right? Oops, I just click on them. Match those 2 up, boom. Okay, quadratic pattern, that's a trinomial, so that's 3 terms. Sum and difference, that's just add respect to 2 terms, it's a binomial, so that's 2 terms. And then the GCF is always what you should do first. On every problem, you look for a GCF first. All right, so nice little check for understanding right there. Will all polynomials factor? Okay, and the answer to that is no, not every polynomial is factorable. We learned that back with quadratics, okay, when we couldn't factor all the quadratic trinomials and we had to use the quadratic formula, right? So not every polynomial is factorable.